Hello students, welcome to my channel Engineer Ash Ma'am. In this video, I am going to solve 25 multiple choice questions of SOM subject. Topic is stress strain. Okay, so let's get started. Question number 1. Modular ratio of two materials is a ratio of, answer is C, their modulus of elasticity. We know that modular ratio is denoted by symbol A, which is equal to ratio of modulus of elasticity. For example, steel and concrete, modular ratio is a ratio of Young's modulus or modulus of elasticity of steel upon modulus of elasticity of concrete. Therefore, answer is C. Second, the linear stress to linear strain is called as modulus of elasticity E. We know that Hooke's law. According to Hooke's law, stress is directly proportional to strain within elastic limit. And to remove this proportionality sign, we introduce one constant, which is equal to E. Therefore, E becomes stress upon strain. Therefore, linear stress to linear strain is called as modulus of elasticity. Therefore, answer is B. Question number 3. The ratio of lateral strain to linear strain is lateral strain E lateral upon linear strain is equal to Poisson's ratio. Therefore, answer is D. Next is Young's modulus may be defined as Young's modulus and modulus of elasticity is nothing but same, which is equal to E, and is the ratio of linear stress to linear strain. Where is answer? Linear stress to linear strain. C. C is correct here. Linear stress to linear strain. Next is modulus of rigidity may be defined as the ratio of Young's modulus, modulus of rigidity, bulk modulus. These are elastic constants. And G. Modulus of rigidity is denoted by symbol G, which is equal to shear stress, and said shear stress to shear strain. Shear stress upon shear strain. Therefore, G equal to shear stress upon shear strain. And Young's modulus is linear stress upon linear strain. Therefore, answer is D. Next, the ratio of change in volume to original volume is called as the ratio of change in volume to original volume, or change in volume to original volume is called as volumetric strain. Answer is C. Volumetric strain is the ratio of change in volume to original volume. Answer is D. Next is unit of stress. In SI unit is, we know that stress equal to internal resistive force upon area or force upon area. We know that unit of force is Newton and a unit of area is meter square. We can write as Newton per mm square, kilonewton per mm square. Okay, it means all options are correct here. Any one of these. Answer D is correct. Next is deformation per unit length. Okay. For example, if it is length L and deformation is here delta L, then deformation per unit length is called as strain. E. Answer D is correct here. Hooke's law holds good up to elastic limit. We know that within elastic limit, Hooke's law is applicable. That is, stress is directly proportional to strain within elastic limit. Answer is B. The unit of modulus of elasticity is same as those of. We know that modulus of elasticity is denoted by symbol E, which is equal to stress upon strain, and unit of stress is Newton per meter square, and unit of E. E is unitless, so ratio of two lengths, change in length and original length. Therefore, is unitless. Therefore, unit of Young's modulus is Newton per meter square. And Stress. Unit of stress is Newton per meter square. Strain is unitless. Next, stress, force and modulus of force. Unit of force is Newton. Again, this answer cancel. Strain. Unit of strain is unitless. And next, stress. Unit of stress is Newton per meter square. Pressure, Newton per meter square. Modulus of rigidity, Newton per meter square. Therefore, answer is B. When a change in length takes place, the strain is known as change in length. When change in length takes place, then strain is known as linear strain. Therefore, answer is A. When a body is subjected to two equal and opposite pulls, for example, if it is body and if subjected to two equal and opposite pull, as a result of which the body tends to extend its length. Okay. Extend its length. This was original length. Now it's extended length. L plus dl. The stress and strain induced is called as tensile stress and tensile strain. Where is option C? Tensile stress and tensile strain. Answer C is correct. Next, when a body is subjected to two equal and opposite forces acting tangentially across the resisting section, as a result of which the body tends to shear off across the section, the stress and strain induced is. For example, if it is body and it tends to acting tangentially across two result, if two forces acting tangentially, then these two blocks will be split into two parts and shear force will develop here at this section. Okay, therefore shear stress will develop at this section. Therefore shear stress and shear strain. D is correct. D, shear stress and shear strain will induce. The modulus of elasticity for mild steel is approximately equal to modulus of elasticity of mild steel is equal to 210 kilonewton per meter square. Answer is D. The Poisson's ratio for steel varies from 0.23 to 0.27. Answer A is correct here. Next, when a body is subjected to three mutually perpendicular stresses of equal intensity, the ratio of direct stress to corresponding volumetric strain is known as bulk modulus. We know that bulk modulus is denoted by symbol K, which is equal to, it's the ratio of direct stress upon volumetric strain. So bulk modulus K is the ratio of direct stress and volumetric strain. Therefore, answer C is correct here. Next, the ratio of shear modulus to modulus of elasticity for Poisson's ratio of 0.4 will be. This is numerical. What is given? We have to find shear modulus to ratio of shear modulus. That is, shear modulus is denoted by symbol G and modulus of elasticity equal to question mark. Okay, we know that E, relation between E and G equal to 2G 1 plus mu. Therefore, take 1 upon 1 plus mu. 2 plus 2 in bracket 1 plus mu at left hand side and E at right hand side. Therefore, it becomes G upon E. Okay, therefore, G upon E equal to 1 upon 2 plus 1 plus mu is 0.4. We know that 1 upon 2 is 1 upon 2. This 1 upon 2 is 0.5 and 1 plus 0.4 is 1.4, which is equal to 5 upon 14. Therefore, ratio of G and E equal to 5 upon 14. This is the answer. Next is the Young's modulus of material is 125 GPa. Young's modulus E equal to 125 GPa. And Poisson's ratio mu equal to 0.25. We have to find modulus of rigidity of the material. Modulus of rigidity is denoted by symbol G. Okay, we know that E equal to 2 G 1 plus mu. E is given, that is 125 equal to 2G. G is unknown. 1 plus mu is 0.25. Therefore, 125 equal to 1 plus 0.25 is 1.25. 2 into 1.25 into G. Therefore, G equal to 125 upon 2 into 1.25. 1 and this becomes 100 and 2 this becomes 50. Therefore, G equal to 50 GPa. Next, principal plane is plane on which the shear stress is. Answer is 0. Principal plane is the plane where shear stress is 0. Okay, only normal stress at there. Answer A is correct. The maximum shear stress is equal to the radius of Mohr circle. So if it is a Mohr circle, then the radius of this Mohr circle is nothing but maximum shear stress. Answer is correct. The sentence is correct. Okay. Next, the energy stored in body when strained within elastic limits is known as energy stored in a body when strained within elastic limit is known as strain energy. Store energy, strain energy, that's why we called it as strain energy. Answer C is correct. Next is the ultimate tensile stress for mild steel. The ultimate tensile stress of mild steel is dashed as the ultimate stress of compressive stress. Answer is more than. The ultimate tensile stress for mild steel is more than the ultimate compressive stress. Answer C is correct here. Next is the maximum stress produced in bar of tapering section is, answer is smaller end. The maximum stress will produce in taper bar. For example, if it is taper bar, then maximum stress will produce at smaller end. This is smaller end. You know that stress equal to force upon area. It means stress is inversely proportional to area. Okay. Stress will be maximum if area is minimum. If stress is maximum, then area should be minimum because both are inversely proportional to each other. Therefore, the maximum stress produced in bar of tapering section is at this smaller section, okay, or smaller end. Last question of this video, question number 25. A bar of length L meters, length equal to L meters, extend by small letter L mm. That is, change in length is given L mm, which is equal to 0.001 L meter. The tensile force of V, the strain produced on the bar is, we know that strain is denoted by symbol E, is change in length upon original length. And change in length is 0.001 L and original length is L. Therefore, answer is D. Done. Thank you. Like, share and subscribe to my channel.